Very good evening, students. Welcome to our channel of learning. So, today we are going to continue the topic 1 of matrices fundamentals. So, it is a part 4 video. We are going to cover further types of matrices. Here, first you should know geometrical view. We have discussed square is geometrical concept. Rectangular matrix is also a geometrical concept. In third part, I covered row matrix, column matrix. It resembles two lines perpendicular. Two lines are perpendicular. Geometrical sense. Next one, we are going to see triangular matrix. We won't write matrix in that fashion. Always we represent either in rectangular fashion or square pattern. Why the name we are using triangular matrix, that we are going to discuss. And two special type of matrices also I will be covering in the same video. In the very beginning, when I gave the notations, capital A, capital B, capital C, capital D, comma, I and O also I wrote there. There I focused I and O are mainly used for two special type of matrices. Those two things I am going to name them. Without any further delay, let us start our class today. It is already very clear on the board. Matrices, topic 1, fundamentals only. Part 4 video. That's why it is a continuation, because we are discussing types of matrices. So in this part 4, we are going to cover fifth one. If I am not wrong, square matrix, first type. Rectangular matrix, second type. Third one, row matrix. Fourth one, column matrix. Fifth one. Here we discuss triangular matrices. I wrote matrices, plural form. Triangular matrices. These are of two types. Upper triangular matrix. Number 2, quite opposite, lower triangular matrix. So first we cover these two. Just like previous video, how to remember easily without any ambiguity. Ambiguity means this may be correct or that may be correct. Confusion state. To avoid confusion state, one should know how to define with more confident in one line, so that the person who is receiving that answer should be clear what you are saying without any confusion. That is called ambiguity. If ambiguity is there, once the answer is revealed, the person will be in a dilemma which one to accept. That should not be there. Whether you are a student or a faculty also, this is a common point to be remembered. There should not be any ambiguity in delivering the concept or receiving the concept. That's the main idea why I am teaching these video classes damn slow. So all these parts of the videos will cover level 1 to higher level, so that school students level to higher grade level, BTech level, all topic concepts will be covered. So I request students, please focus on every letter on the board and how you can able to recall it. That's the main motto from my side to deliver these lectures. Right? If any doubts are there regarding the previous videos, whatever you watched, don't hesitate to post your comments. If you want to know further details about the same topic, so that I can able to elaborate. So I am focusing complete area of the topic where you are very clear about that. You will not get any further extra doubts also in that context only. Keeping in view those boundaries, topics are covered very effectively. So, this is about triangular matrices. Two will be there. That's why I wrote matrices, plural form. Upper triangular matrix, lower triangular matrix. How we have to identify how they look like. It is very simple. First one, upper triangular matrix. To define upper triangular matrix, you should have one basic type of matrix in the beginning of start. It may be a rectangular, it may be a square. For these type of matrices, we should consider only square matrices. Only square matrices, this is applicable. This is applicable. If if I take A3, A3 stands for A is a square matrix of size 3 by 3. It contains 3 rows and 3 columns. It's all been told. Same notations I am using here. If A3 is a square matrix, compulsory square matrix you have to pick up. Because I wrote A3, let us elaborate this. How you write A3? Already I defined. Because we are using capital A, you can take it is 3 by 3. For more convenience sake, 3 rows, 3 columns. So 3 A's, and each row and each column must contain 3 elements. Right? Here, as usual, you know how to name the elements. Just I am writing down without dictating, because you are aware of this. How to name the elements. If A3 is a square matrix of type, I write type. What I will do, because a square matrix it is diagonal, it is called diagonal. This is called diagonal. This is called main diagonal. Main diagonal. Main diagonal. In some books they write principal diagonal. Both are same. Right? Upper triangular matrix. It should be a square matrix of any size. Here I took 3. We can take 4. We can take 5. We can take 6. The pattern is same. Only thing is that elements keep on increasing. So you can able to draw this diagonal like that. Right? So this diagonal, whatever the number you take, not equal to 0, some number, negative or positive. Here also not equal to 0. Here also not equal to 0. This one from diagonal and above, move above. All these elements must be not equal to 0. Not equal to 0 in sense they can be either positive numbers or negative numbers, but not 0. And below the diagonal, it should be, they should be zeros. Simple to answer these things. A square matrix in which elements, how they look like, main diagonal and above, they are non-zeros. Below the main diagonal, all zeros. One line sentence, a square matrix is said to be upper triangular matrix if the elements below the main diagonal are all zeros. So just I'll give you a small matrix here with the numbers, same A3 for idea's sake. So I write 7, 4, 2, 5, 2, 11. You see, missing elements are, it is main diagonal. They are non-zeros. And above also non-zeros as I stated there. Below the diagonal, the remaining three elements will be zeros. Just we will observe triangle above like this. Matrix, diagonal. Here elements will be there. Below the diagonal, zeros will be there. Upper triangular matrix. If you just switch the definition, lower triangle matrix we can define. How you want to define the same thing? Just quite opposite. We write same A3 here, diagonal and below are non-zeros. Above the main diagonal, elements must be zeros. So mostly students will get confused. Upper triangular matrix means above the diagonal zeros. Lower means below the diagonal zeros. Ambiguity. Elements should be non-zero above for upper. Elements should be non-zero below diagonal. Let us, I will finish off the other example also for lower triangular matrix so that you get clarity on those two. It is general way of writing representation of the main diagonal. I gave you notations there. One example. Here I took only positive numbers. You can take positive, negative or all negative but not zeros. Here these three elements and above the six elements should not be zeros. Below that must be zero. It is called upper. Above upper. Below lower. Below lower. So hope you understood how to remember without any confusion. Now I'll finish off the next part. Second one, second type, lower. Lower triangular matrix. Same. If here I want to take A4, a square matrix of size 4 by 4, 4 rows, 4 columns. So how you write? A4, the square matrix, we write here A11, A12, A13, A14. 4 rows, 4 columns, 4 columns over. Next row, second row, I'm filling second row elements. Third row elements. Last fourth row elements. Is a square matrix. As I wrote in the beginning of the square matrix of type. How it must look? Same. Identify the principal diagonal or main diagonal. It is already, it is called main diagonal. Main diagonal or principal diagonal. Same way. Now lower triangle means the elements of this main diagonal and below must not be zero. I highlight with the other color. This element should be not equal to 0, not equal to 0, not equal to 0, not equal to 0. Here also, not equal to 0, not equal to 0, not equal to 0, not equal to 0, not equal to 0. Means they can be positive or negative. Above elements, how many are there? 1, 2, 3, 4, 5, 6. These elements must be zeros. One, two, three, four, five, six. For example, I take A4 only here also. Randomly I have selected numbers. You will see diagonal and below, all the elements are non-zeros. Above that main diagonal, elements are zeros. That's why it is called lower triangular matrix. Diagonal and below, elements should be non-zero. Above must be zero. So sometimes you may get any one of the elements may be zeros, but the condition is that here the diagonal element must contain at least one non-zero. Always you won't get all zeros. At least one element, either in first upper triangle matrix, lower triangle matrix, you may get some zeros also. That is not countable there. The thing is that above the main diagonal must be zeros. There, below the main diagonal must be zeros. That is the condition. You give preference for this triangle. Zeros triangle, you keep it in mind. If the zeros you find a triangle pattern above the diagonal, above means lower, we quite opposite. If you find the triangle pattern of zeros below, perfectly below the, diagonal, the main diagonal, upper triangular matrix. So avoid confusion in noting down these two differences. Next, I told you in type 6, I'm going to give you special type of matrices. And further, one more thing is there. Instead of covering in this video, we will go to next part so that there will be a different matrix called tri-diagonal matrix. Tri means three. Diagonals, three diagonals matrix. How to represent? There also we have to take square matrix only. Square matrices play a vital role in different types. So without further delay, I am going to mention that sixth one, two special type of matrices. So type 6 special type matrices. So these two special type of matrices you should remember because we are giving two fixed notations for that. One is capital I. Capital I. It is called identity matrix. It is also called unit matrix. So here also the same thing. Base matrix is square. If I take I3, size will be 3. Here no need to take small I here. As I told, if you take capital letter, same letter you can write there because it is special type of matrix or matrix 2 are there. One is I3. You can take I4, I2. Only square matrix, but the letter should be I. That's why identity matrix or unit matrix. Simply the main diagonal elements must be 1. The main diagonal elements must be 1. Remove the other elements, the remaining elements above this and below this must be 0. Must be 0. It is I3. If I want to write I2, you can show 1, 0, 0, 1. Here also square matrix 2 by 2. Diagonal elements must be 1. And why it is called special? These matrices are used in computer graphics to rotate the images, to shift the images, all those things in geometrical application of the gaming theory, computer games, video games, how you are going to see the motion of the objects or the cartoons in your monitor. In computer graphics, matrices play a vital role. So among that, this type of matrix play a vital role to get color formats. One indicates black, 0 indicates white. If you find more ones, more black, more zeros, more white, some zeros, some ones, we get gray colors. So all colors are generated making use of these type of matrices in computer graphics. It is about identity matrix, and the next one is first one. Under the first one, second one, I gave one more notation for that. Second one, O. It is not zero, it is capital O in our English alphabet. Here, the matrix need not be square. It may be rectangular or square. Suppose if I take O3, it is a square matrix of order 3 by 3. So, every element will be 0. All the elements will be 0. And the name of this one, null matrix. Null matrix is also called zero matrix. Because of this word, we in some textbooks they write O as 0. They treat O as 0 because of zero matrix. But strictly speaking, in matrices, we are going to name using uppercase letters. Here O stands for capital O. Because of this name, zero matrix, we will treat O as 0. It is not number 0. Number 0. So O3, you can take a rectangular matrix also. We write O, suppose if you write 3 by 2. It is rectangular matrix. It's square matrix. How you write? Very easy. It has 3 rows, 2 columns. Done. Here also every element is 0, but it is rectangular. It is square. That is the difference. So for null matrix or zero matrix, the given matrix may be square or rectangular. Doesn't make any difference because every entry or every element is 0 in this. Hope you are clear about these two types. In next video, I am going to cover further more types. So do share and subscribe our channel so that many students can get benefit of it. Hope you enjoyed. Keep watching, keep learning, keep learning. All the best. God bless you.